Given question, determine the reactions developed at supports A and B of the overhanging beam as shown in the diagram.
Let us understand given question with the help of diagram. This is the question of overhanging beam. If we observe at point A, beam is hinged and it is free to rotate about point A. So reaction at point A can be in any direction, and we will show horizontal component and vertical component for this reaction. At point B, roller support is given and which rests on the horizontal surface. So we have to show the reaction at point B perpendicular to the horizontal surface. And we have to find out the value of reaction at point A as well as reaction at point B. We will first draw the free body diagram. We will first show the horizontal component and vertical component at point A. So horizontal component we will show as a HA and vertical component we will show VA. And we have to find out these two unknown value HA as well as VA. Now if we move to the next point then 39.9 Newton meter moment is given and which is in clockwise direction. So we have to show that, and distance in between this is 3 meter. 39.9 Newton meter. So this is the moment given. Now next is given 31 Newton and which is inclined at an angle of 45 degree. Now we will resolve this force into two components, horizontal component and vertical component. So here is vertical component and here is horizontal component. So for the horizontal component we will show 31 cos of 45 and vertical component 31 sin of 45. Now we will move to the next point B. Now here roller support is given. So for roller support we have to show the reaction which is perpendicular to this horizontal surface, and that is known as RB. So we have to show direction towards the beam, and here is RB. We have to also find out reaction at this point B. Now if we observe for the remaining portion there is no any support, and that's why it is known as overhanging beam. Now for this portion after point B, uniformly distributed load is given. So we will write here uniformly distributed load and how to find out magnitude. Now this uniformly distributed load is given 20 Newton for 1 meter, and this load is distributed over 2 meter length. So magnitude is equal to 20 multiplied by 2. So this is the magnitude of uniformly distributed load. Now where is the point of application? So for uniformly distributed load we have to take the middle point. So for this 2 meter we have to take middle point, that is on both sides 1 meter distance is there. So we will show here the point of application and the direction is in the downward direction. Magnitude is 20 multiplied by 2. And here point of application is the middle point of 2. So we will show here the distance, that is distance in between this B and this point of application is 1 meter. So this is the free body diagram. Now how to find out HA, VA and RB. Now if we observe here two unknowns at point A, that is HA and VA. So we will consider the equilibrium of this system. So when we consider equilibrium of the system, then we can write summation of moment of all the forces about any point is equal to 0. Summation of horizontal forces is equal to 0 and summation of all vertical forces is equal to 0. Now at point A there are two unknown. So if we take summation of moment of all these forces about point A is equal to 0, then this HA and VA will become 0 because these two components acting at point A, and there is only one unknown remaining RB, and we can calculate the value of RB. So we will take here summation of moment of all the forces about point A is equal to 0. Now first we will take here 39.9 Newton meter. Now here the moment is given. So I will write here 39.9. So here no force but the direct moment is given in terms of Newton meter, and the direction is in clockwise direction. So for clockwise direction we will use positive sign. So we have to write only 39.9 Newton meter. So this moment is given in terms of force multiplied by perpendicular distance. This whole value is nothing but force multiplied by perpendicular distance. So we will directly write this. Now we will move to the next. So next is 31. So horizontal component, if I extend the line of action, then it is passing through A. So perpendicular distance is 0. Now we will move to the vertical component. So for the vertical component, perpendicular distance is 3 plus 2, that is 5. And if I move the compass in the direction of 31 sin 45, then it is in this clockwise direction. So we will use positive sign. So plus 31 sin 45 multiplied by 5. Now we will move next, that is this 20 multiplied by 2. Now this is the uniformly distributed load. Magnitude is 20 multiplied by 2. Now this magnitude multiplied by the perpendicular distance from A. So how to find out? 3 plus 2 plus 1 and here remaining 1. That is 5 plus 6, 7. So total distance is 7 meter. And if I move the compass about point A in the direction of 20 multiplied by 2, then it is also in clockwise direction. So we have to take plus 20 multiplied by 2 into 7. Now what about RB? So we have to find out this. Now if I move the compass in the direction of RB, then here is the anti-clockwise direction and here we will use negative sign. So minus RB into perpendicular distance, 3 plus 2 plus 1. That is 6. So minus RB into 6 is equal to 0. So RB is equal to 71 Newton. So this is the answer. Now we will find out HA. So summation of all horizontal forces is equal to 0. So if we observe horizontal forces, that means this horizontal component. So HA, both are in opposite direction. So we will take plus HA minus 31 cos 45. That means for this sign we will use positive, that is for this direction we will use positive sign, and the direction towards left hand side we will use negative sign. So HA value when we calculate, it is plus 21 Newton. So for positive sign, direction of HA is this. Now we will move to calculate VA. So summation of all vertical forces is equal to 0. Now if we observe, here is VA, that is upward direction. For upward direction we will use positive sign and for downward direction we will use negative sign. So plus VA minus 31 sin 45 plus RB minus 20 into 2. So this is in the downward direction is equal to 0. So only one unknown term VA, and VA is equal to minus 9.8 Newton. So here for minus sign we have to show direction, that is the downward direction. So VA is equal to 9.8 Newton and we have to show downward direction. So how we can change this? So the answer is VA is in the downward direction. So I will write here, I will show here VA. And it's a 9.8 Newton and HA 21 Newton. So we will remove this. So here is the VA and HA. So how we can show the RA, that is the reaction at point A? So we have to show here in this direction. So in this direction RA, that is the reaction at point A, is acting.